video, we're going to talk about the connection between the factored form of a quadratic equation and the intercepts of a graph, specifically the x-intercepts. At the top of your notes here, which you should print using the link in the description box or using the link that you got from your teacher, you'll want to have these notes with you printed so that you can follow along and fill them in as we go. If you don't have a printer, you can still follow along just by watching, but for best results, we highly recommend that you print this. So let's begin with some helpful reminders. In a lesson shortly before we left for this break, we learned that the x-intercepts have a connection to the factored form. The x-intercepts are the opposite of the factors in parentheses. So for example, in the factored form y equals x minus 4 times x plus 1, we would notice that graph would cross the x-axis at 4, 0, 4 being the opposite of negative 4, and negative 1, 0, negative 1 being the opposite of the plus 1 we see in parentheses here. So that first bullet point is really the connection between the x-intercept and the factored form. You can find the x-coordinate of your vertex halfway between your x-intercepts, also known as the midpoint of the x-intercepts. And the y-coordinate for your vertex can be found by plugging in the x-coordinate that you found in the middle and then solving for y, which we will show in an example down here. The line of symmetry is a vertical line through the midpoint, which is known as the middle of the x-intercepts. It's also just a vertical line through the vertex. The y-intercept is found by plugging in 0 for x. So let's begin with example 1. What I can see here immediately is that my x-intercepts are going to be located at 1, 0 and negative 3, 0. I'll place them on the graph here. 1, 0 and negative 3, 0. So we know that our vertex is going to be located halfway between those two. So there's a total of 4 units between these two. So exactly 2 units between these two, right here, this is where we'll have our line of symmetry. And we know that our vertex is going to be along this line right here. So now I know that the x-coordinate of my vertex is going to be at negative 1, because negative 1 is halfway between my x-intercepts. So my vertex will have an x-coordinate of negative 1, and to find the y-coordinate of the vertex, we're going to plug in negative 1 and see what comes out. So to find the y-coordinate, I'm going to begin with y equals, and instead of x, I'm going to plug in negative 1. So I took my x-coordinate for my vertex, and I plugged it in here to see what comes out for y. Also, that's negative 2 times positive 2, which is negative 4. Yes, you could have done that in your head. I'm just saying, if you have a calculator, don't forget you can always use it. So my y value for my vertex is at negative 4. So here I'm going to go down 1, 2, 3, 4. Now, since I don't have anything in front of my parentheses here, what I should expect is that this will be a regular 1, 3, 5, 7 pattern. So starting at your vertex, it's going to go up 1 and out 1. Then the next time we go out, we'll see that it goes up 3, which it does. That's how we get to our x-intercepts. And from there, it would go up 5. And then from there, it would go up 7, but we don't have enough room to do that. So then I'll connect here. And what I just noticed is that I can actually find the y-intercept from the graph I just created. It's down here at negative 3. However, if for some reason you were graphing your parabola and you weren't able to see the point where your graph crossed the y-axis, another thing that you can do is find it algebraically the same way that we just found the y-coordinate of the vertex. So what you can do to solve for the y-intercept It's where x equals 0 here along the y-axis where x equals 0. So what I can do is I can plug in 0 in for my x's. And you can solve it algebraically that way. You'll see that when we solved it algebraically, we got the same result as by solving it graphically. Either way, you'll get the correct answer, but you want to have the algebraic method in your back pocket in case you are graphing and you find that the y-intercept isn't visible on the given graph. We're going to begin example 2 the same way. I notice from my factored form that the x-intercepts will be located at 2, 0, and 6, 0, taking the opposite of the factors in the parentheses. So we have 2, 0, and 6, 0. So our line of symmetry is halfway between, which is here at x equals 4, which means that the vertex is also going to have an x-coordinate of 4. To find the y-coordinate of the vertex, we're going to plug the x-coordinate in and see what comes out. So if x equals 4 and y, also known as f of x, equals 1/2 times 4 minus 2 times 4 minus 6. Which is 1 times -2, which is -2. But again, if you need to use your calculator, or if you would like to use your calculator throughout this process, you can. So our y-coordinate for our vertex is at -2. So our vertex is here. So instead of being a 1, 3, 5, 7 pattern, all of this is cut in half. So it's like up 1/2 over 1, up 1.5 over 1, and then up 2.5 over 1, etc. So to find the next points in this, you would have to take that pattern and continue it. All right, so I'm going to be honest here. I started doing way too much. I was explaining how to take this 1, 3, 5, 7 pattern and break it in half, thus moving in a 1/2, 1.5 pattern, which I didn't like the halves, so then I was combining them so that every time you went out 2, I knew exactly how much to move up. So it would have been 2, 6, etc. If you don't need that, that's fine. So next we're going to find the y-intercept of our parabola. And to do that, we need to plug in 0 for x. So when x equals 0, and I did kind of just find this graphically, but I know graphing with an a value of 1/2 can be kind of challenging for some people. So I want to show you how to do this algebraically in addition to graphically. So instead of 1/2 times x minus 2, now we have 0 minus 2, and then 0 minus 6. So that's half of -2 times -6. So that's 1/2 times -2 times -6. -2 times -6 is positive 12, and half of 12 is 6. So the y value for the y-intercept should be at 6. 1, 2, 3, 4, 5, 6. So I know I graphed that correctly. All right, our final example here, example 3, has one factor that just says -x, and the other factor says x plus 4. So we're clearly going to have an x-intercept at -4. And since the other term is just x, another way of thinking about that is like x plus 0. So our other x-intercept is at 0. So anytime you have a factored form like this, where instead of having x with something in parentheses, it's just x by itself, whether it's positive or negative, it's going to have an x-intercept of 0. So those are our two x-intercepts. And this negative sign out front is going to tell us that our graph is opening upside down. So when we go to find our vertex, we know that this graph should be opening upside down, but algebraically, that will take care of it anyway. So our line of symmetry is still located between these two here. and that's at x equals -2. Our vertex is going to have an x coordinate of -2 because it's going to be located along this line here. And to find our y value, we're going to plug our x coordinate into our function. Notice that because our x value has a negative, when we plug it into -x, that becomes -2. So be careful when you're layering in with negatives. Keep track of all of your signs. So when we start solving this out, this is going to become -2 is +2 times -2 plus 4, which is +2. So our y value is 4. So the y value of our vertex is up here. And since our a value is a -1, we should see that 1, 3, 5, 7 pattern. So every time we go out 1, it's going to go down 1, and then 1, 2, 3. Yep, we already have that here. And then from here it's 5. And then 7, which we don't have room for. So graphically, we found our y-intercept here at 0, 0. Also, just knowing that we have an x-intercept at 0, 0, the point 0, 0 is technically on both the x-axis and the y-axis, so that let me know that the y-intercept was going to be at 0, 0 also. Since I have graphical evidence and I already know that my x-intercept's at 0, 0, you don't need to go and find this algebraically. But just remember, anytime that you would need to find it algebraically, you could always just plug in 0. So I'll show what that would have looked like if for some reason you weren't working with a graph. It's -0 times 0 plus 4. So -0 times 0 plus 4, -0 doesn't even matter, but 0 times 4 is 0. So our y-intercept is 0 at 0, 0, which we already knew from the x-intercept. All right, I hope you found this helpful going through these examples for factored form and intercepts. Once you get the hang of it, this process is quite simple, and you're really just doing the same things over and over. We have lots of materials linked online for you this week. So your job now that you've seen this video is to complete your online practice, complete your paper practice, visit office hours with us this week, take your quiz on factored form and intercepts, which is a Google form that will be available to you this Thursday and Friday. Have a great week. -2 times -6 is -12. In a lesson shortly before we left so our y value for our y-intercept should be 4.